Hey folks, Vern Jackson here, founder of Light-Based Technologies back in 2003. Unfortunately, that company was scammed by fraud, which kind of left everybody, including the investors, hanging. This is pulse width, unlimited, infinite bipolar technology that I created back in about 2007, actually. What this is a complete infinite analog version that requires no processors. Any clock or sign can be used. I'm currently using 120 hertz for this sample. It can be an analog sine wave, it can be triangular shaped waves, any kind of wave technology can be used and pass through in a linear state of some form or not. It doesn't have to be linear actually. It can hit the high and low margins as well. That can be separated into two separate points for the pulse width system here. This design I created back in that time period was primarily for lamp control and LED control at the time, but I soon realized that this circuitry that I designed, because it's bipolar and has positive and negative feedback ability, can be used for any robotic technology whatsoever to allow a sense and feedback control circuitry for every motor and function or junction point in the sensing and operation of any machine given. For example, you could have hundreds of these circuits, one for each motor control, all using a common clock or signal base, which is typical in a per se, but each sensor, each junction has an analog state of self-regulation to some point we call center. Then any deviation of information, such as a want to do or an application of a function change, is simply a means of adding or subtracting a value in place of the sensor, which in this case I'm using as a phototransistor to modulate the output to that lamp there. Now what this circuitry has several things on board. AC coming in first of all, and that is in the 12 volt range. It gets converted by two rectifiers on board, bridge types, and you'll see that in the circuitry I'll show you after. And then from there, one of the bridge rectifiers feeds a DC circuit to run the chip, the clock, and so on and so forth, which, like I said, I'm running at 120 hertz in this version. Typical two-chip gate clock. Um, the output is separate. It runs on the power supply as well, but it uses its own bridge for a 1 amp source, which I'm currently using to run this lamp. Now you can see as I close the phototransistor off, that's typically your feedback, a high and low, to the point where I can actually self-shunt the lamp pretty much off visibly. Using any other external source, you can do the same. Not a problem there. So it shows the power. Now the other interesting thing is you can use this to modulate a light source if you wish, like a cigarette lighter, let's say. I can bring that in. Now that kind of a lamp is slow, but I'll show you how this circuit works in another few applications. Uh, the lamps I have here are all built back in '09 using the same principles, and you can see the dates on there. '09, I believe. Yeah, right there. Okay, now these were built as a custom job. Currently they use 12 volts. These are used in your 6 to 12 watt LEDs from Citizens is what I used back then. Those were the only ones making high power lamps at the time. Now these are self-regulated using the same circuit. The only difference is that it's internal. The Instead of using an optical sensor, I use a transistor and it measures the temperature of the case. When the case starts to get a little warm, I have it set to drop the current back in the light slightly, and that limits it to a temperature based on the fixture that it's mounted in, which essentially makes them bulletproof. These lamps will outlast the LEDs. End of story. You can put a new LED back in here after 300 million hours or whatever, and you're all set to go again. Here's another sample. This version here is a 12 watt LED using the same circuitry. Now in this case I put an eye in the front. You can see that down here on the bottom right there. Okay, and that dims the light. It takes that reflection from my hand and modulates the light. Like I said, and the same with a lighter. You can use a cigarette lighter. So the fact is that this technology not only modulates for current sensing, temperature sensing, etc., but also can be used as a form of language communication between devices, let's say. Simply by modulating that light source, you can pass technology through there, information-wise, no problem. Anyway, just another sample of how these fixtures are custom. I built, by the way, out of aluminum extrusions with the end caps cut, water jetted, and so on. And then I use plastic elements in here for um, the lens diffuser, which is just kind of a frosty type material. And another point of interest that may be cool is I have seen a few people out there playing with fans and stuff like that. And yeah, this is a 100-watt unit. Okay, a pair of 50-watt LEDs, right? These work on about 48 to 50 volts each at 1 amp a pop. The same circuit can actually be used to run these lamps, no problem. You run it at the tail end. The fan allows for cooling, like you say, any computer, PC type stuff. And I'll show you some photos from that stuff back in 2007 and 8 period. That was done, developed, and already assembled and ready to go. Thanks very much for your time. Hello, folks. Just to continue on where I left off with the pulse width analog, this is an infinite bipolar technology, like I mentioned previous, which allows a full positive or negative feedback structure. Now, what I was showing you previous was how to control temperature and optical switching. Now, the thing is the design of the circuit allows you to, for example, in this case, I've put a live source to the input value, which turns this lamp on to its high. Now the high side of the lamp is internally regulated also by temperature override, which allows the lamp now to run at full capacity under any condition. Now this here allows you to override the temperature sensing with a simple loop that goes to ground. So when it goes to ground, it shuts the lamp off. I can put any kind of a resistive sensor in there, optical sensor, transistor sensor, or any other device that has simply a pull low capacity. Doesn't matter what it is. Switch, mechanical for that matter, whatever. And now you've got full control over that lighting system, which can also be used to modulate the light in some way if you wish. Being lead tech, they respond pretty quick, and that's the story on those. Now, when I talk about the LEDs I've used for these devices, this goes back to the early days. Let me just move these things out of the way here, and I'll show you what they're all about. There we go. These are some of the early LEDs that I used back in the days from Citizens Electronics. This goes back a little while. Yeah, I bought these about '08, '09 roughly. Actually '08 because I experimented, probably '07 I would think, because I was experimenting with these at the time. And we've got different watt levels and different luminance types, color range, whites, so on. What, like your 2700K type up to your 6000K level type LEDs at different wattages and horsepower levels. Um, these are some of the 48 to 50 watt LED units that I was using there, like I showed you before. They're kind of cool. Yeah, big square patch of just a ton of LEDs in series, in a sense. More of them here. These are 6-watt units in the bar style, which I used uh, in a few of these types of lamps actually inside. And I'll be showing you a still photo arrangement of these in another clip along with my stuff here. This is another type. Different K level, the brightness quality, like the color temperature is what changes in those. They're kind of cool. Interior automotive applications, that kind of stuff. These ones here are like a little square die chip type deal. A little more roundy than square. These are like 6-watt range type LEDs in different K values. Let's see here. Yeah, Some of them over there. A bunch of those there. Yeah, these were all purchased way back 08, 09 range, right? These are your 12-watt units. Yeah, there's a lot of sizzle out of one of those. I got a bunch of these. Yeah, they're really nice LEDs. I like those. Like I said, they were Citizens. I can focus up on that a little and show you. And this camera's not all that great, folks. Kind of lame, but you can see Citizens there. Anyway, I'll be giving you the circuits and all of the other design material for these in still frame shots coming up after these clips. Thanks very much. Hello, folks. This is a sample of 2008 material. The bulbs you see here are fan bulbs. 2008 prototypes. Cool. There's the fan at the back with the aluminum around the outside. These were for par bulbs, par 50, 60 type stuff. Yeah, kind of cool. There's the LED up front for the 12-watt unit. There's the fans and the gear. This is going back to 2008, folks. Actually, these were developed in 2007, and then the final was like 2008 when they were ready to go after a lot of design and so on and so forth. Some other stuff that went along in the high power world way back. Yeah, high power LEDs for my car, toys, that kind of stuff. Anyway, just a little sample.